Hello, what's going on everybody? We're going to go over 875 Koko eating bananas. This is a popular binary search problem and it's very interesting because you're going to use binary search in ways that maybe you haven't in previous problems. So we're going to go over the description real quick. Koko loves to eat bananas and there are n piles of bananas. So the ith pile has piles of I bananas. And the guards have gone and will come back in h hours. So Koko can decide her bananas per hour eating speed of k. So for each hour, she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas at the end of it, she eats all of them instead and will not eat any more bananas during this hour. So that means Koko won't, let's say Koko's eating speed is 4 and eats the first 3 bananas from this pile. She's not going to eat the first one out of this pile. She's just going to stop eating for that hour. So we just need to return the minimum integer such that she can eat all bananas within h hours, so before the guards come back. Okay, so we're just going to visualize this problem and make sure we have a real good understanding of what's being asked. So let's say this is our pile. So we have 3, 6, 7, 11, and h is going to be equal to 8, right? So h is the hours until, 8 is the hours until the guards come back. So we need to decide some eating speed such that for each hour, by the 8th hour, all the bananas are done eating. So if we start with 1, for example, and let's just say, okay, let's start with the minimum number 1. So Koko will be eating 1 banana per hour. So we're going to take 1 from this, so making this 2. And that's going to decrease the hours to 7. Take 1 more banana from this pile. This makes it 6. Now this pile is empty and we have 5 hours left to eat all the bananas. And we're going to start eating from this pile. So 5, 4, and take another one from here. 4, 3, 3, 2, 2, 1, 1, 0. So we have a lot of bananas left and we've reached the hour limit. So the guards are going to come back and find that Koko's eating all of the good bananas. So this isn't going to work. Let me clear this out real quick. Right. Let's see. Let's get this out of here. All right. Let's get that. Okay. And now let's say our eating speed is 2 instead. So this would drop down to 1. So this would just erase this. Okay. So we're eating at 2 bananas per hour. This makes this 1. And now we have 7 hours left. And remember, this now becomes 0. And we're not going to eat any more bananas from the other pile. We're just going to stop eating. So we have 6 hours left. Eat 2 from here. This makes it 4. This makes it 5. 2, 4. We're done with this pile. And now we have 3 hours left. Okay, so take 2 from here, this makes it 5. We have 2 hours left. Take 2 from here, that makes it 3 bananas left. 1 more hour, 1 banana left in this pile, and now we have no hours left. We still have bananas left in the pile, so that's not going to work. And we would just keep doing this until we find the next eating speed that makes it so we eat all the bananas within h hours. Right? Okay. So we can definitely check 3, but since the answer is already 4, I'm going to just go over that real quick so it makes sense. So if Koko's bananas per hour eating speed is 4, this pile is already done. This makes it 0. And now we have 7 hours left. Take 4 from here. This makes it 2. 6 hours left. Okay. Take the remaining from here, 5 hours left. Take 4 from here, 3. Okay, this makes it 0. Okay, we take 4 from here, that makes it 7. Right? Now we have 2 hours left. Take 4 from here, that makes it 3. We have 1 hour left, and we eat the remaining bananas within H hours. So our output is going to be 4. So K would be 4. All right. Let me clean this up real quick. All right, and let me just clean this. I'll just start a new. Okay. So now we're just going to go over how to use binary search, right? How are we going to build up binary search to find that specific number we're looking for? If we look at the maximum number here, which is 11, we know for a fact that if we choose 11 to be our bananas per hour eating speed, we would be able to eat all the bananas within H hours, right? We would eat this pile, eat this pile, eat this pile, eat this pile, and have about 4 hours left remaining. But the question is asking for the minimum integer, K. So if you think about it, our minimum eating speed can be 1, and our maximum can be 11, or anything past 11 would work too. But since we want to limit our range, we can say our range is 1 to 11, right? So there's some number K in here that allows us to eat all the bananas within H hours, and we want the minimum. So what we're gonna do is use binary search, right? So if our low is gonna be 1 and our max is gonna be 11, our maximum value in the array, we're gonna keep computing the middle value and make sure that it follows the constraint, we're going to eat all the bananas within H hours, right? So let me explain this. We're going to first have a function called kworks, and it's going to take the piles, the number of hours, and some value K within that range, like 1 to 11. Okay, and what we're going to do is make sure that, okay, if the K value in this range, if we eat all the bananas in that K speed, it's going to be less than or equal to H, right? So remember when we chose 1 to be our eating speed, there were so many hours left because if we eat at 1 banana per hour, we're not going to eat all the bananas within H hours, so that would fail. Same thing with 2 and 3, right? So this Boolean function is going to determine that we would be able to eat all those bananas within H hours. Okay, so we're going to have some variable hours and set that equal to 0. Okay, and then we're just going to return hours is less than or equal to H. So can eat all bananas within H hours for K speed, right? Okay, so now we're going to look through each element in the array. So for int pile, int piles. And what we're going to do is increment hours by the K speed. So let's say our K speed was 1. If we do, was it 3 divided by 1? So let's see, hours plus equal, and I'll explain this in a second. So pile divided by K, and then it would need to be double. Okay. So what this does is determines how many hours it will take to eat that pile. Okay, so if our value is k and the first element is 3, what we do is take that pile, which is 3, divide it by 1, and that's going to take 3 hours, right? That's going to take 3 hours to eat this pile. And if we do 6, so now hours would be 3, right? So hours is 3 because we did plus equals. And now we go to the next pile, which is 6. So if we do 6 divided by 1, that's going to be 6. And obviously if you do 3 plus 6 equals 9, that's greater than h. So this would fail. And you keep doing this. We're going to check the different values in the range by using binary search. Okay? Okay. And now we're going to determine that range that we were talking about. So we know the left one is going to be 1, and the right is going to be the maximum of that array. So we're going to say, let's just say piles at index 0, and then we'll compute the max. Okay, so for int pile in piles, we're going to say right equals math.max right pile. And for the first example, this would just be 11. Okay? And this is where the binary search comes into play. So we're going to say while left is less than right, we're going to compute our k, which is going to be the middle value. So int k equals left plus right divided by 2. And then we check if that k value, that middle value we're looking at, if it satisfies this condition. So if k works, piles hk, if we know that works, then we're gonna shift the right pointer to this value. So we're gonna say right equals k. Else, if we get some low value like 1, where we have several hours left, that value is too little, which means it's not going to work. We have to shift the left pointer to k plus 1, because we know that's not going to work, right? So left is going to be equal to k plus 1. And all we have to do at this point is just return left. Okay. And let's check this out. Let's run this. Okay, so that one works. And that one works as well. So yeah, this is the binary search solution. We returned left because eventually there's only going to be one value. Like if we eventually reach 4, for example, then we exit the condition when left is equal to right. And so that means we can even return right, and it would still work. Okay, so this is how we use binary search to find this answer, and we also use the ceiling function, which rounds the value up, right? Because we know if we're dividing the pile by the eating speed, we need to eat at most those bananas, so we have to get the ceiling of that. We don't round down because there might be a banana left or something like that. We consider whole values only. So hopefully that makes sense. This is when our range has already been considered, and we just look for the middle value in this range and keep computing that until we kind of converge towards this minimum value, right? And that's basically it. That's Koko eating bananas. Fun binary search problem. Can definitely stretch your thinking and help you build up solutions to binary search. So yeah, hopefully that was helpful. I'm going to make more of these videos soon. Thank you so much.